Hello, this is Mrs. Carlton's Algebra Unit Review, or Mr. Dudley's Chapter 3 Review. This will be parts 1 through 3. So you're going to have 3 tests we're getting you ready for here, no matter what your teacher calls this unit. All right, let's get rolling. First one is expressions and equations. Remember, expressions don't have equal signs. Equations do. They have variables and numbers and equal signs. Expressions just variables and numbers. So the product of a number the product of a number and 5 plus 20. So we really got a couple of things here. The product of a number and 5. This would have to be, that's multiplication, so that would be 5 times a number. And then plus 20 would be here, increased by 20 or plus 20. Remember, on the test, you're going to have to label these things, and you can use the words right from the test. So I might show this as 5x or 5xn, 5 times the number n, and this here, you can write increased by 20. Again, I encourage you on the test to use the words that are actually on the sheet. Now, they're not going to be on your answer sheet, but they will be on the test sheet that is on Schoology or in the test question. A number less 6, this would be like an n minus 6. Here would be your number. And here would be less 6. So it's really easy to do. You just have to do it to get the credit. It's an important step. 8 less than a number is 10. So here's that number, and here's 8 less, and here's what it's equal to. So this would be is 10. This is a number. This would be less 8. See how we just put it together? All right. The difference of a number and 7 times 11. The difference of a number and 7, times 11. The difference of a number and 7 times 11. Well, when you see this word difference here, you know that it's going to have a set of parentheses in it. The difference between a number and 7, well, that would be an n minus 7, so we can just even label this. This is the diff between n and 7. And then you can just put the 11 right out front here. This is 11x, or 11 times that. Okay, the quotient of a number and 5 less 4 is equal to 12. Okay, so the quotient of a number and 5, so here's the division. Here's the number and 5. It just comes right in that order. Quotient. Use hashtag for number and 5. Minus 4, that's going to be that less 4. Equals 12. So the quotient of a number 5 less 4 is 12. You can see how when you check your work, how easy that is to do. All right. Now you're writing equations for situations. 20 points is 15 more points. 20 points is 15 more points than Sam scored last game. Write an equation to find out the score Sam had last game. All right, so we have to think about a variable here. Let's just use points. So we know that it's going to equal 20. So we can say that the points he had last game plus the 15 this game is equal to 20 points. So here's the points called points game 1. Here's the 15 more. And this would be the total points this game, or game 2, I guess you could call it. So let me double check that. Here's the points. Here's the 15 increased. and there's the total points. Points is equal to 15 plus the points he had last game, 2. So this one here might be maybe better representative of the situation. Okay, here's the total. These are the 15 extra, 15 more. This is points last game. So either one of these would be acceptable. All right. 80 less than a number is 200. Well, again, here's the easy part, is 200. So 80 less than a number. So here's that number, here's the less 80, and there's the equal to 200. So here's a number. Here's the less 80. Is 200. Again, all of these little writings with these arrows, this is what you're going to have to do on the answer sheet of the test. You'll be able to look at the question, but you're not going to be able to circle and draw arrows to it on the test because we didn't write the questions on the test. We just gave you a blank spot that says, write your answer, label it. Total number of players on the team, we're separated into 6 groups. So here's the players. They're separated into 6 groups. Each group had 8 players. So here's the total players. I'm going to put a long arrow. 6 groups. And 8 players each group. Okay. 2 pairs of pants are purchased for $115. So you know this can equal $115. And there's 2 pairs of pants, and so you can multiply those. It would be like 2 pants equal 115. So this would be 2 pairs. This would be the cost of the pants. And this would be the total. All right, I can solve equations with additions. All of these here, you're going to have to, put all these in. Just put railroad tracks for all of these. All right, the railroad tracks. This is exactly the way it will look on the test. They'll have the railroad tracks in, so just kind of get used to it. So this is 15 plus v, so we need to subtract the 15 from both sides to get rid of the 15 and to isolate the variable. So I did it on both sides to balance it, and you got v equals 7 here. And you can take and put 7 in up there to make sure that that works. That would be 15 plus 7 is 22. Here's another one. Here we got the plus 12, so we got to subtract 12 from both sides. Sorry, that didn't come out right. I have to make a big ugly subtraction sign. There we go. 12 minus 12, those cross off. You've got x isolated. And then 63 minus 12, 3 minus 2 is 1. 6 minus 1 is 5. So that's 51 equals x. Again, you could just pop it in there. 51 plus 12 would be 63 if you think about it. 51 and 12. Here's your 3 and here's your 6. You'll notice how I'm always putting them in. Whenever I substitute a variable in, I substitute it in parentheses. I think if you start that habit, it'll make your life much easier as you move on through pre-algebra and algebra. All right. N minus 10 equals 2. So these are subtraction equations. So let me get rid of that by adding. Plus 10 minus 10, that's 0. We've isolated n by balancing the equation. 2 plus 10 is 12. Let me just put it in here. 12 minus 10 equals 2. Yeah, that looks good. 13 equals k minus 20. Well, we've got to get rid of that minus 20, so we'll add it to both sides. We've got k isolated. 13 plus 20 is 33. Let me just pop that in there. 33 minus 20 is 13. Nice. Yeah, I know it looks like a 5, but that's a 3. Nobody said I was perfect. Well, a couple people did, and they were really smart. Okay, page 2, let's see what we got here. I can solve equations with multiplication. And then we've got division, then we got the old two-steppers. So I'm just going to go ahead and make my railroad tracks here. Okay, 144 equals 12c. Well, we have to divide by 12 on both sides. 12 divided by 12 is 1c, or just c. 144 divided by 12 is just 12. You just pop it in here and see if it works. 12 times 12 is 144. That's good. Okay, here we have to divide by 20 on both sides to isolate it, because 20w is 20 times w, so the opposite is division. 20 divided by 20 is 1w, or just w. 200 divided by 20 is 10. Just pop that 10 in there and make sure that works. 20 times 10 is 200. Well, 2 times 1 is 2, plus the 2 zeros. There's your 200. So this dude is good. Okay, 22 equals some number m divided by 3. Well, the opposite of divide by 3 is to multiply by 3, so I'm going to put that. And notice how I've got it nice and high, because it's really like 3 over 1. And then I'm going to go over here and squeeze it in here. I'm just going to cross this off so this doesn't confuse us. The problem number, so I'm just going to do it 3 times 22 up there. The 3's on this side cross out. You end up with m is equal to 3 times 22, which is 66. So let me pop that in, make sure that works. 66 divided by 3 is 22. Good. Okay, same thing here. Cross this out so I have a little more room to work and you're not confused with the problem number. Some quantity z divided by 12 equals 4. Well, we get rid of divide by z by multiplying by z. I'm going to put it way off to the side over here. And notice how it's nice and high. It's not 1/12. It's 12 over 1. The 12's cross out here. And we just have z isolated, and that equals 48. Let me just pop this in there. 48. 48 divided by 12 is 4. That worked out just fine. So here now we've got these two-step equations. And remember, in a two-step equation, I told my kids it's like going outside to play in the snow. When you go outside to play in the snow, you put your snow pants on and your boots, but when you come inside, you have to reverse that order. You have to take your boots off first and then take your snow pants off. It's the same thing with when you're trying to isolate a variable, you're trying to undo this equation, you have to use the reverse order of operations. So instead of dealing with multiplication and division first, we're going to deal with addition or subtraction first. So we start by subtracting 2 on this one from both sides. That leaves us with 6j equals 12. 6j is 6 times j, so the opposite of times is division, so we'll divide both sides by 6. 6 divided by 6 is just j, or 1j, and 12 divided by 6 is 2. So we can pop this in here, see if it works. 6 times j is, well, 6 times 2 is 12, plus 2 is 14, so my answer is correct. Now, a lot of teachers like when you circle the answers, and I certainly do too. If you want to go back and do that on the first ones, it is really nice. The more clear your work is, the better chance you're going to get full credit. All right, so m divided by 4 minus 5 is equal to 10. So first of all, we're going to get rid of that minus 5 by adding 5 to both sides. Plus 5 minus 5 is 0. We're just left with m divided by 4 equals 10 plus 5, which is 15. So let's take and multiply by 4 on both sides. But the 4 is crossed off. You've isolated m. And 15 times 4 is 60. Let's just pop that in and make sure it works. 60 divided by 4 is 15. Minus 5 is 10. Good. Alrighty. Alrighty then. Okay, so we have some tables to complete here. We're completing this table for 2x plus 3 and write the order pairs. Use 0, 1, 2, and 3 for your values. So what I do here is I always just I write and I put parentheses in for my variable. I think that's, as I mentioned, the smartest way to do it. So instead of 2x plus 3, I have 2 with parentheses plus 3. So I can just fill my variables in here, 0, 1, 2, and 3, and then go to work. 2 times 0 is 0, plus 3. Well, 0 plus 3 is 3. And then my first ordered pair is right here. It's 0, 3. So I can write that over here, 0, 3. Put in parentheses. 2 times 1 is 2, plus 3 is 5. So my next ordered pair then is 1, 5. Okay, 2 times 2 is 4, plus 3 is 7. And here's my next ordered pair, 2, 7. And we've got 2 times 3 is 6. Plus 3 is 9. And we can take a look at that last ordered pair, 3, 9. Okay, we're going to do the same thing on this one here. We've just got a different equation here. We have something divided by 3 plus 7. So I'm just going to write that one like this. Use that slash for division. It's one of those situations where that does work a little bit nicer, especially if I could write that so small it'd be hard to read. So now I'm just going to fill in my variables. My variables for the first x variable is 3, and then we have 6, 9, and 12. You can see how this is going to work out pretty smoothly because they're all multiples of 3. So 3 divided by 3 is 1, plus 7 is 8. So here's my first ordered pair, 3, 8. Okay. Then I have 6 divided by 3. Well, 6 divided by 3 is 2. 2 plus 7 is 9. So I can put that down. 6 and then 9. That's my ordered pair. 6 and 9. Okay, now I've got 9 divided by 3, which is 3, plus 7 is 10. So there's my next ordered pair. 9 and 10. And then we've got 12 divided by 3, which is 4. 4 plus 7 is 11, so here's my next ordered pair. 12 and 11. Okay. Alrighty then. Looks good. Let's keep moving. Got 2 more pages left. There's not quite as many problems on each page. All right, which equation, when solved, matches the graph above? Make a table to check the equations. Okay, what I like to do on these is I like to make a table right up here for the graph. And this is an especially nice graph because you can see the points pretty well. Here's 0. Let's see if I can get it a little bit bigger. I can't. Sorry, folks. It's as big as I can get. I can get 0 is my first coordinate, my x and my y. So the 0 and it crosses the y at 1, 2, 3. So I have 0, 3 is my 1 coordinate. And then this, of course, would be 1 right here. So 1 is going to be over 1 and then up 1, 2, 3, 4, 5. And then for 2, let's see if I'm going to get a good coordinate there. It looks like I am 2. And this will be 2. So it's 1, 2, 3, 4, 5, 6, 7, 2, 7. So I've got 3 good points there. I could do 3 as well. 3, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like 3 and 9. So I've got a table here that I can check and just see. Well, let's just pop this one in and see if it works. I have to pop in 0. 3 times 0. 3 times 0 is 0. Plus 2 is not 3. So it cannot be this table. All right, this one's got a minus 2x. Let's just pop the, well, first of all, we'll pop the 0 in. negative 2 times 0, 0 times anything is 0, plus 4 is 4, not 3. It can't be that table. Let's pop this one in here. 2 times 0 is 0, plus 3 is 3. Well, so far this one looks like it's good, but let me try the other ones. 3 times 2, or 2 times 2 would be 4, plus 3 is 7, so it works for that one. Let's pop the 1 in. 2 times 1 is 2, plus 3 is 5, so it works for up here too. It looks like this is working for all of them, but I'm going to check all of them. 2 times 3 would be 6, plus 3 is 9. So it looks like this is the correct answer, but I'm pretty thorough dude, so I'm going to check this other one. I'll put 0 in. A negative 0, well, negative x, 0 is 0. Minus 2 is minus 2. No, this one doesn't work. So C is your correct answer there. I think the most important part right here. Mrs. Carlton's got it. Big, huge hint. Make a table. All right. Let's go down and try this one. You need to plot some of these points on the graph. A is 2, negative 3. So here's over 2. And we've got negative 3. 1, 2, 3. So here's 2, negative 3, that first point. Got that dude done. We can label that point A. And then we have 3, 0. So I'm going to go over 3 and then up 0. That's point B. And then I've got negative 5, negative 6 for C. So negative 5 is back, negative 5. And then negative 6, that's way down here. Negative 5, negative 6. This is point C. And then we've got 0, 2, over 0 and up 2. So we've got points all over the place. We've got a couple on the axes. This is on the y-axis. Point D is. Point B is on the x. We've got a point down here in quadrant 4. And we've got C down here in quadrant 3. Remember, this is quadrant 1, 2, 3, and 4. That won't be on the test, just a reminder. And then remember that you're always going to go over first and then go up or down. This is kind of the key to everything. And if you wanted to make it a little more interesting, you could add in a few things. If you're going to go, if it's a negative, you're going to go backwards. If it's a positive, you're going to go forward. If it's a positive, you're going to go up. If it's negative, you're going to go down. Hence, let's just take a tough point like C here. We had negative 5, negative 6. We have to go backwards first, and then we're going to go down. I know. It's a gift. Keep rolling. Now we have to write an equation for the following table. This is going to be okay. I mean, we've got the table right there. We've got the XY table. And we've got a bunch of equations. We just have to match it. So let's take a look here. And just to make it a little bit simpler, I'm going to rewrite this right here. Here's my X and my Y. And they gave us 2, 3, 4, 5. 2, 3, 4, and 5. And my values are 6, 9, 12, 15. 6, 9, 12, and 15. Well, I'm going to substitute in the 2, one value. So why don't I write it over here this time so you can see what I'm doing. So I'll just do 3 times 2 minus 1. Now, if this works, 3 times 2 minus 1, it's going to have to come up to be 6. So 3 times 2 is 6, minus 1 is 5. So that can't be the answer. It did not work for it's got to work for all values, and it didn't work for that one, so I can cross that dude out. So now we've got 2x minus 4. So let's just this would be the x minus 4. And if that's going to work, it's got to be equal to 9, right? So let's just pop it in. The x, let's use 2 again. That's nice and easy. 2 times 2 is 4. Minus 4 equals 0. It doesn't equal 9. So this dude can't be this dude. 3x. So y is equal to 3, and I'll just put a set parentheses. So let me just pop in the 2 here. 3 times 2 equals 6. Well, there's my 6. So that worked. Let's try a couple others. Y equals 3. I'll put in the 3 value for the x. That equals 9. There's my 9. Y equals 3. I'll put in the 4. And that does equal, there's my 12. This is it. There's the 15, and there's the 15. So we got them all. 2, 3, 4, 5. 2, 3, 4, 5. There's my x values, and 6, 9, 12, 15. Good. Let's just try this last one, just to be thorough. Y equals x plus 10. We'll just put in the 2 here. 2 plus 10 is 12, not 6. Cross that dude out. All right, y equals 3x on that one. Okay, here we go. Write an equation that matches the following table. I'm just going to make the table a little bit smaller right here. I think it's easier for me to read. Again, I'm never too lazy to write things out the way they're going to help me get the answer correct. So my values, my y values are 3, 5, 7, 9. 3, 5, 7, 9. Let me double check, make sure I got my table right. 0, 1, 2, 3, 0, 1, 2, 3. 3, 5, 7, 9, 3, 5, 7, 9. There we go. All right, let's take a look here. All right, y is equal to 2 times some x plus 1. Let's put the 0 in. 2 times 2 is 0 plus 1. This would equal 1. Yeah, it's not 3, so it can't be that one right there. Y is equal to, let's just put in 5 times something plus 1. Well, substitute in 0. 5 times 0 is 0 plus 1 is 1. Can't be this dude right here. All right, this next one, y is equal to 3 times something plus 4. Okay, again, let's just use the 0 one. It's a real easy one to use. 3 times 0 is 0, plus 4 is not 3. So it can't be this dude. And y is equal to plus 4. Let's see, This is y is equal to 4 times, y is equal to 4 times something minus 10. You get the minus sign big. So let's just pop in the 0. Y is equal to 4 times 0, which is 0 minus 10 is equals minus 10. So none of these work. So how do we find what this equation is? Well, we can think about, first of all, our y-intercept. On this problem here, let me just make a little graph here. We can think about the line. It has 0, 3, so we go over 0 and up 3. When you see that right there, you know that your y-intercept, this is where it's going to go through the y-axis right here. So we know that this is going to have to be plus 3. So it's going to have to be something x plus 3. Now it could be multiplication and division. But let's just see what else we got here. Let's graph these other points. We got 1, 5. So we got over 1 up 5. And we've got over 2 up 7. And again, I'm just arrow graphing. Then over 3 up 9. So this would kind of be my line here. Oh, that's a pretty steep line. So I'm thinking it's something times x plus 3. So let's just try a couple here. Well, let's just see if it could be x plus 3. Could it possibly just be x plus 3? Well, let's put in the 0. 0 plus 3 is 3. So that's 0, 3. That one works. Let's put in 1. 1 plus 3 is 4, not 5. Okay, so it can't be x plus 3. Let's try 2 times x plus 3. Well, let's put it in the 0. 2 times 0 plus 3 is 3. So that one works. 0, 3 works. Let's put in the 1 value. 2 times 1 is 2, plus 3 is 5. Yeah, that one worked. Let's try another one here. 2 times 2. That's the next value. 2 times 2 is 4 plus 3. Well, that would be 7. So far, this is all working out. We may as well be thorough and check this fourth one. 2 times 3 plus 3. Well, 2 times 3 is 6, plus 3 is 9. So that one worked out. So your equation for this one is, I'll put a nice box here, y is equal to 2 times x plus 3. All right, y equals 2x plus 3. All right, so that was kind of a trick question. A, B, C, or D didn't work. I'd be curious to see how many of you picked one of those and how you could justify your answer. So if you substitute in, 0 value for all of them, all I did was substitute in the 0 value, and every single one of them was wrong. So, all right, just a reminder, if you're going to be doing this and you're going to be making a table, use 0, 1, 2, 3 if you get to pick, or 0, 1, 2. 0 is the easiest number to work with. All right, thanks. Have a good day.